Okay, what's going on, guys? We have a coaxial cable. That means there is a current inside and a current outside of that wire, and then we have to measure or to find out an expression of the magnetic field within the three factors: the inner and the space between conductor and the outer space. So what I did is that I took the formula of the magnetic field multiplied by the distance equal the constant multiplied by the current, and we know that the circumference or the distance inside the wire is 2πr, or the magnetic field of the wire, depending on the distance anywhere, is going to be constant multiplied by 2p divided by 2πr. That's mean distance. So what we're going to do in this question is that we're going to integrate the formula, but it depends on the big radius and the small radius. That's mean the R1 and R2. So what I did is that I took the magnetic field is going to be equal the constant multiplied by the current multiplied by the big radius derivative of the big radius divided by 2πr2. And then we have to integrate this one between R1 and R2. And then the magnetic field is going to be equal, take out the constant, that's the constant multiplied by current divided by 2p. And then we have to integrate R1 and R2 in the distance of the radius R1 and R2. And then the magnetic field force or strength is going to be equal constant multiplied by the current divided by 2π R1 derivative of R1 divided by R2. And then we have to multiply by R2 and R1. So this thing will give us magnetic field equal constant multiplied by the current multiplied by R1 divided by, well, actually it's multiplied by R2 derivative of R1, and then 2π R multiplied by actually R2 and R1 here. And then with the radius R1 and the top one, they're going to cancel out, and one of the R2 is going to cancel out. So we left with the magnetic field multiplied by the constant multiplied by the current R1 divided by 2π R2 square. In question number B, so we have to do a graph. And the graph is going to be equal, if you enter, let's say this is R radius and this is the field strength. So what I did is that I just took from R equal 1 to R equal 6, and then we know that R equal to R2 if R1 equal 1/3 of R2, and then you're going to take this formula here, the magnetic field equal constant multiplied by the current multiplied by R1 divided by 2π R2 square of the second radius, and then you can go replace the radius from 1 to 6 in this formula, depends on what they are asking us in this formula. So this is what it gives, the result or the graphic that it showed. So let's go from the result that I got, and then okay, so R1 is going to be, from R0 is going to be 0, that's for sure. R1, it did give me 33, that's all the way to the top. And then B is 33.3 minus 8, it's going to be around here. And then R3 is going to be 2 power of minus 8. R4 is going to be 1.6, somewhere around here. And then it's going to be 1.1. So it's going to be this kind of graphic, if I'm not mistaken.